We will be looking at the mechanics paper of June 2018. Question 6, at time t seconds, t is positive, a particle p moves in the xy plane. The velocity v is given in vector form. When t is 1, p is at the point A, and when t is 4, p is at the point B. We need to actually find the exact distance AB. So we can actually integrate to get the displacement vector. We call this R. So if we integrate, we get t to the a half over a half for I minus 4t squared over 2j plus a constant of integration which is given in vector form. This simplifies to 2t to the a half I minus 2t squared j plus c. When t is 1, I will substitute to get the position vector for point A in terms of the constant of integration, c. It's giving me 2i minus 2j plus c. And when t is 4, you get 2 times 4 to the half I minus 2 times 4 squared j plus c again, which is 4i minus 32j plus c. We need to find the distance between A and B, so it's just going to be the difference between the two position vectors, and therefore the c will cancel out. So the vector AB will be the 4i minus 32j plus c. Take away 2i minus 2j plus c, which gives 2i minus 30j. We have to find the exact distance AB, which means it could possibly be in third form. So the distance AB is simply found by applying Pythagoras. And this is giving us an answer of 2 root 226. That was question 6, the first question of the mechanics paper. In question 7, we're being given a wooden crate of mass 20 kilos is pulled in a straight line. Tan alpha is 3 over 4. The tension in the handle is 40 newtons. Mu is 0.14. And we need to find the acceleration of the crate. So we can start off by resolving the 40 newtons. Horizontally, we will be having 40 cos alpha. And then vertically, it's going to be 40 sine alpha. I will also add the weight here, 20g. So I will also draw a triangle here to extract the values of cos alpha and sine alpha. So knowing that tan alpha is 3 over 4, it's a Pythagorean triplet, this is 5. So cos alpha is 4 over 5 and sine alpha is 3 over 5. We know that we have a normal reaction force here. I will call it R. We know that the coefficient of friction between the crate and the floor is 0.14. So to start off with, we can say that R plus 40 sine alpha is equal to 20g. Using g to be 9.8 and sine alpha to be 3/5, we will be able to obtain the value of R, which is the reaction force. This turns out to be 172 newtons. We know that the frictional force now will be mu R. So to find the acceleration, we've got acceleration towards the right. I'm just going to do 40 cos alpha minus mu R equals ma, mass times acceleration. So we know that cos alpha is 4/5. Mu is 0.14, and we found R to be 172. So we'll do all of that and then divide by 20 to get the answer. And we get an answer of 0.396, and that's meters per square second. The crate is now pushed along the same floor using the handle. The handle is again inclined at the same angle alpha to the floor, and the thrust is 40 newtons as shown in the figure. Explain briefly why the acceleration would now be less than the acceleration of the crate found in part A. So for 2 marks, no calculations needed. We just need to realize that because we've got this push now, 40 newtons, the reaction force will increase. So what we need to say is that pushing will increase the reaction force, and this will increase friction. Thus resulting to a decreased acceleration. So it's because we are pushing now, we've got, apart from the 20g, we've got this component here, the 40 sine alpha, that's making this reaction force greater and therefore increasing the resistive forces and therefore reducing the acceleration. In question 8, we're being given that the particle is moving with constant acceleration. We have the initial velocity 2 minus 3, and we know that after 2 seconds, it's at point A with position vector 7 minus 10. To find the acceleration, we'll be using R equals ut plus a half at squared. So this will be 2 minus 3 times 2. We know the position vector after 2 seconds, that's 7 minus 10, plus a half a times 2 squared. This will give us 7 minus 10 is equal to 4 minus 6 plus 2a. And if we solve, we get a to be 3/2 minus 2, we are asked to find the magnitude of this acceleration. So the magnitude will be 3 over 2 squared plus negative 2 squared and all square root, which is 2.5 meters per square second as required. Now in B, we're being told that the instant when P leaves point A, the acceleration of P changes so that P now moves with constant acceleration of 8.8. At the instant when P reaches the point B, the direction of motion of P is northeast. Find the time it takes for P to travel from A to B. So we can start by seeking to find the velocity at A. So we have the initial velocity was 2 minus 3. We have now the acceleration vector form, 3 over 2 comma minus 2. So we can use that to find the velocity at A. So for velocity at A, we will be using V is U plus AT. The initial velocity was 2 minus 3. The acceleration is 3 over 2 minus 2. We know that the time to get to A was 2 seconds, and this is giving a result of 5 minus 7. That's the initial velocity as we embark on a journey from A to B with a constant acceleration of 8.8. We also know that as we reach point B, the direction of motion of P is northeast. So if we just consider what that means, if I'm moving northeast, I'm moving parallel to 1, 1. So I'm going diagonally northeast. So we have the acceleration, we've got the initial velocity, and what we could do is use V is U plus AT again. This time the initial velocity is 5 minus 7. The acceleration has been given to be 8.8 t. So this is the journey from A to B. And we know that this will be parallel to 1, 1. So 5 plus 4t is lambda, and minus 7 plus 8.8t is lambda. If we deduct, we get 12 minus 4.8t is 0, leading to t being 2.5 seconds. Remember that if two vectors are parallel, it means that one is a multiple of the other, and therefore it's lambda times 1, 1. The answer is 2.5 seconds. That was question 8 of this paper. Question 9 speaks about a plank, has a mass of m and length of 2a. It's resting against the rough vertical wall. It's being held in a horizontal position by a rope. The plank is uniform, so we will start by adding the forces. We've got 3 mg for the particle P. We've got the mass of the plank itself, mg, at a distance of a from A, halfway through. We also have the tension in the rope, which we will resolve into T sine alpha and T cos alpha. We know that tan alpha is 3 over 4, so I will quickly be drawing a triangle to actually determine sine alpha cos alpha. So sine alpha is 3 over 5, cos alpha is 4 over 5. We need to show that the tension is 5 mg, 3x plus a over 6a. So I will take moments about a. So if we take moments about a, we see that the clockwise moments will be 3 mg times x plus mga, and this will be equal to t sine alpha times 2a. mg is a common factor on the left, leaving with 3x plus a in the brackets. Sine alpha is 3 over 5 times 2a. So 5 mg brackets 3x plus a is 6at, leading to t being 5 mg 3x plus a over 6a as required. So that was the first part of the question. We took moments about a, clockwise moments equals anti-clockwise moments, and we found an expression for T, the tension in the rope. The magnitude of the horizontal component of the force exerted on the plank by A, on the plank at A by the wall, is 2 mg, and we have to find x in terms of A. It says for 2 marks. So if we go back to the diagram, the magnitude of the horizontal component of the force exerted on the plank at A. So that is a force here. And this force here has a magnitude of 2 mg. So it's obvious that what we can do is set these two equal because they are the only horizontal forces acting. So 2 mg is going to be T cos alpha. Now 2 mg, we have the value of T, it's 5 mg, 3x plus a over 6a, and cos alpha, which is 4 over 5. Now the mg's go away, the 5 with the 5 will cancel out, the 6 with the 4 leaves me a 2 and a 3. So if I cross multiply, I get 6a is 6x plus 2a. I need to find x in terms of a. 4a is 6x, so 2a over 3 is equal to x. So that's x in terms of a. Part C, we're told that the force exerted on the plank at A by the wall is acting in a direction that makes an angle β with the horizontal. So if we just revisit the diagram, we've got the force here that creates an angle β with the horizontal, and therefore we've got a vertical component here as well, which I will call F. Now the idea is for us to find the vertical component F, so that when we actually close the triangle here, that will be F, that will be 2 mg, and that will allow us to find tan β. So in order to find F, we need to consider the vertical and horizontal forces. We've got vertically T sine alpha and F, and downwards is mg and 3 mg. So we have that F plus T sine alpha is equal to 3 mg plus mg. Now we have already established that from part A, that the tension is 5 mg 3x plus a over 6a. So I will replace that. So this is f plus 5 mg 3x plus a over 6a. In the place of sine alpha, we will be replacing the value we obtained. We had it before. Sine alpha is 3 over 5. So let's put the 3 over 5 there. And this is equal to 4 mg. Now we will start by looking at simplifications, the 5 with the 5, the 6 with the 3. We also know from before that 3x is 2a. So this is f plus mg 2a plus a over 2a is equal to 4 mg. And this leads to f plus 3 mg over 2 is equal to 4 mg. And therefore f is 5 mg over 2. So that's the vertical component of the force. So if we quickly draw a triangle here, this is 5 mg over 2. This was given to be 2 mg, and that was theta. So obviously tan theta is 5 mg over 2 over 2 mg, which is 5 over 4. That was part C. In part D, we're told that the rope will break if the tension exceeds 5 mg, and we need to explain how this will restrict the possible positions of P, fully justifying our answers. Now, we have an expression for the tension from the very first part, this. So that will be the starting point. We know that the tension cannot exceed that value. So we can start off by saying 5 mg 3x plus a over 6a has to be less than or equal to 5 mg. Now the 5 mg's go away, and therefore this leads to 3x plus a less than or equal to 6a, or simply that x must be less than or equal to 5a over 3. Remember that a is fixed, we only control x, and we conclude that for the rope not to break, the block cannot be more than 5a over 3 from a. So that was the last part of question 9. In question 10, we've got the ball throwing a ball at the target. The initial point, the launching point, is 2 meters above horizontal ground with a speed u at an angle alpha. So we can start off by resolving into the horizontal and vertical components, u cos alpha and u sine alpha respectively. We know that the acceleration is a negative g. The highest point reached is 3 meters above ground, and at this point the velocity is 0. So in order to show that u squared is 2g over sine squared alpha, what we can do is consider vertical motion with the equation of v squared is u squared plus 2as. So 0 squared will be u sine alpha squared plus 2 times minus g times 1. The displacement is 1 because we set off 2 meters above ground. We reached a height of 3 meters above ground, so this is just 1 meter. So if we just rearrange all of these, we get 2g is u squared sine squared alpha, and therefore u squared is 2g over sine squared alpha as required. Now in B, we're being told that the point T is at a horizontal distance of 20 meters from A and at a height of 0.75 meters above ground, and we're told that the ball reaches T without hitting the ground. So we know that this distance here from T horizontally is 20 meters, and the vertical is 0.75 meters. And we're being asked for 9 marks to find the size of angle alpha. We can start by considering horizontal motion. So horizontally there is no acceleration. So S is simply ut, and we know that 20 is u cos alpha t. And then we could consider vertical motion. Again, with S is ut plus a half at squared. We do know that we are 0.75 meters above ground, which means that the distance below the launching point is simply 2 minus 0.75, which is 1.25 meters. So that's my displacement. It's actually minus 1.25 because I'm 1.25 meters below the launching point. So what we can do here is say that minus 1.25 is u sine alpha t plus a half minus g t squared. We also have the result from the horizontal motion. So we need to find a way of substituting for t. So we can say that from the previous equation, t is 20 over u cos alpha. So I will substitute this into the vertical motion. This will give me minus 1.25 equals u sine alpha times 20 over u cos alpha minus a half g 20 over u cos alpha squared. So minus 1.25 will be 20 tan alpha minus 200 g over u squared cos squared alpha. We do know that u squared is 2g over sine squared alpha. So we could actually use this here. So minus 1.25 is 20 tan alpha minus 200g over 2g over sine squared alpha times cos squared alpha. Now the g with the g goes away. The 200 with the 2 give me 100. And all of this leads to minus 1.25 is 20 tan alpha minus 100 tan squared alpha. Why? Because we've got in the denominator we had cos squared over sine squared, which is the same as sine squared alpha over cos squared alpha in the numerator. So this is essentially leading to a quadratic in tan alpha. We've got 100 tan squared alpha minus 20 tan alpha minus 1.25 is 0. So this is a quadratic in tan alpha, which we can factorize into 4 tan alpha minus 1 brackets 100 tan alpha plus 5. Either tan alpha is a quarter or tan alpha is minus 1 over 20. Now we reject the tan alpha being minus 1 over 20 because it would lead to an obtuse angle. We don't want that, so we reject this. So tan alpha is a quarter, which leads to alpha being 14 degrees due to SL. So that was the 9 marks for part B. And then for part C, we need to state the limitation of the model that could affect our answer to part B. So there are quite a few things we could actually say here. So we could go for the standard one about air resistance. So there will be air resistance. Other comments you could say is on the ball having dimensions, wind effects, or the spin of the ball. And then we've got part D. Find the time taken for the ball to travel from A to T. So we need to find the time to go from A to T here. We've got the angle. So what we could do here is actually get together all the information we have extracted up to now. So we knew from part A that u squared is 2g over sine squared alpha. So we can say that u is the root of 2g over sine squared alpha. And we've got the value of tan alpha. So if this is alpha, this is a quarter, so this is root 17. So sine alpha is 1 over root 17. So this is the root of 2g over sine squared alpha is 1 over 17, square root of that. So this will be the exact value of u. And then we've also found that from before that t is 20 over u cos alpha. So I'm just going to use that. So t is 20 over u cos alpha, which is 20 over the value of u, 2g, over 1 over 17, square root of that. Cos alpha, well, cos alpha from the triangle here is just 4 over root 17. And this is giving us a result of 1.1 seconds to 2SF. So that was part D of the final question of this paper. Thank you very much.